So hold on. We thought about geometry when we applied the Pythagorean theorem. And we're finding that when we plug in the critical value that's within the closed interval, that's looking like a result from the Pythagorean theorem as well. The a plus b that we're squaring in there, then adding c squared, taking the square root of that a plus b. Why are we talking about the sum of the heights of the two poles? Okay, well, I'm going to flip over some vertical axis, the triangle that was on the right. Take a look at what we've got here. Can do a little bit more besides the vertical flip. Having done a vertical flip to the triangle on the right, now I've also moved it down. Can you begin to see where the a plus b is coming in? If we extend the vertical line segment from the pole of height A further down, and similarly extend the base of the triangle that had a height of B, they're going to meet up at a right angle, and we have a total over here on the left of a plus b for the length of this overall line segment. Take the solid part plus the dashed part, and along the base here we've got x plus c minus x. Sorry, the c minus x is no longer showing up, but anyway, the total then would be c. Therefore, the value of t at the critical value, where we had the quantity a plus b squared plus c squared, the square root of all of that, would be the length of the hypotenuse of this overall large triangle, where we had a height of a plus b, a base of c. And again, this part right here, that is the length of the hypotenuse. What else? What we have here, that would be the square root of a squared plus x squared, whatever the value of x is within that closed interval 0 to c. And what we have here, this would be the hypotenuse of this right triangle that had a length of, take b squared plus the quantity c minus x got squared, add those two together, take the square root of that, and you get the length of that hypotenuse for whatever the value of x is within the closed interval from 0 to c. Well, the triangle inequality tells us that if a and b are different, then the length of that third side would be less than the sum of the other two. Regardless of whatever the value of x is, as long as it's within that closed interval from 0 to c. Now, if a and b are equal, then these are going to line up nicely. We won't get a third triangle here. I haven't shown it here. Really, it comes up elsewhere in another one of my videos. You could talk about the slope. If a and b are equal, that this line segment would continue on here, giving you the value of the critical points, and then the total length would be 2 times the square root of a squared plus c over 2 squared, if I remember correctly. But in any case, busted. This was not a calculus problem, really. It was a geometry problem. And again, this is whether a and b are equal or not. Hope you watched that all the way through to see how we can be misled by the sound of a problem, what we really need to apply.